Okay, the last one, the hardest part is drawing this free body diagram. So they're pushing this crate of physics equipment, and Adam is pushing straight down on the crate. And then of course you also have the gravity of the crate, and you have friction, and you have the normal force. And then they tell you that Ryan is pushing at some angle 30 degrees below the horizontal. And they want to know what force are they pushing with. Now, one thing that's different in this question is that they give you the force of friction. They give you the force of friction of 692.8 newtons, and they give you the coefficient of friction. And so you could, right off the bat, solve for the normal force. The normal force here would be 796 newtons. So again, you have an angle, so you should be thinking right away, sum of the forces in the x direction is equal to 0 because it says constant velocity, and sum of the forces in the y direction is also equal to 0. So let's split our forces up. We've got negative friction plus this positive component of Fp equals 0. So Fpx is equal to friction. Now, there's two ways you can do this problem. You know that Fpx is equal to Fp cosine of 30, and they gave you the force of friction, 692.8. So you should be able to just solve for the force of the push by dividing both sides by cosine of 30. And when you do that, you do get 800 newtons. Now let's say that you did the forces in the y direction. In the y direction, you have Fn minus mg minus 200 minus Fpy equals 0. You just found Fn up top. You know the mass. You know gravity. And so you could solve for Fpy. That would give you 396 newtons. And you know that Fpy is equal to Fp sine of 30. And so you could also find the force of the push using the y direction. Either way is acceptable.